Welcome to JCon!
Thanks, everybody. We're gonna have, this is kind of a, I kind of love giving this talk, right? We're gonna talk about a number of different philosophies that have kind of emerged in the market and where they came from and how they're all related, and then how that's leading into this process of developer productivity engineering. So for those who I haven't met yet, my name is Justin Reock, Field CTO at Gradle. My background is primarily in software development. I wrote code for a long portion of my career, moved into enterprise architecture, and somehow found myself doing nothing but PowerPoints now, so pretty awesome. When we start this talk, you know, what is this really all about? What's it always been about? It's been about being able to increase our throughput, decrease our cost, right? And for those who've been around the DevOps space for a while, you may recognize this quote. It is no longer the big beating the small, but the fast beating the slow, all right? This is from Eric Pearson, who was CIO of Intercontinental Hotels Group, IHG. This has become a rallying cry for DevOps, right? And what does it really mean? It means it's no longer the giant mega corporations that are really eating the world now. It's the fast, agile companies that are able to get their features out to market quickly and move according to the winds of the market, all right? So how can we be more like this? Well, to talk about this, I love to tap the ancient business wisdom of the 70s and 80s. This is where we really started getting into the science of productivity. And it started with this man, Ellie Goldratt, Dr. Ellie Goldratt, I should say, and the book The Goal. Anybody read The Goal? Anybody? All right, a few of you. Everybody should check this book out. It's really sort of an interesting book. It's Goldratt was a physicist, kind of turned business novelist, right? It wasn't he didn't, you know, set out to be sort of a business analyst. He sort of had this epiphany that you could treat a business like a complex machine, which meant that it would obey the laws of physics, which is really useful because you can't break the laws of physics, so you can make really good predictions based on using a model like this. And you know, his most famous work is called The Theory of Constraints. Anybody heard of the Theory of Constraints? All right, a few more folks. DevOps, Agile, Lean, all of these different practices stem from Goldratt's work, right? And it basically just focuses, like I said, treating organizations as complex machines, but more importantly, focusing on eliminating bottlenecks from these machines. Now, if you haven't read The Goal, who's read The Phoenix Project? Okay, a few more folks. If you open up the blurb to this book, they are shamelessly saying that they totally copied The Goal and just redid it in the spirit of a software company. It's a fun read. The nice thing about both of these books, if you haven't checked them out, they're not like a business textbook or a technical playbook or anything like that. It's like a fictional business drama. Like you kind of put yourself in the shoes of the protagonist. In this case, you know, a software company that's struggling to keep pace with its competition. And you put yourself in the shoes of the VP of engineering of this company facing all kinds of problems. And a change agent comes in and introduces the theory of constraints, and in this case, DevOps. And it kind of goes from there. So highly recommend this book. This is the kind of book, you talk to people who have read this book, and you'll get a lot of reactions like, this book changed my whole perspective on development. This book was like a career game-changing book for me. So definitely check it out. demonstrates the relationship between DevOps and throughput optimization, right, which we're going to talk about a little bit more. Teaches the importance of things like value stream mapping, observability, and continuous improvement. And that really comes down to fundamentally rethinking the way that we structure our business process. So the theory of constraints tells us to kind of boil it down, that any complex machine is really comprised of sort of three elements, right? There's an inventory, kind of the raw material that makes the machine work. There's the cost, right? The energy that provides the torque or whatever to move the machine. And then there's the throughput, the machine actually doing its job, right? But what the theory of constraints shows us and what physics shows us is that actually the cost of the mechanism is less important than that mechanism's throughput, right? This changes our thinking in terms of, okay, well, cost is what we really have to control, but not really, right? The most important thing is that the machine does its job. And so if you could take a quick intellectual leap here and look at a software organization, what does this mean? Well, cost is organizational cost. That doesn't change, right? It's the cost of actually doing the work of producing the inventory, which is code, right? And then throughput for any business is money as a complex machine, okay? So a lot of what the theory of constraints teaches us is that we have to, as much as possible, optimize sort of the distance between the cost of the thing that we're doing and the throughput that comes back to the business. This is where things like continuous deployment came from, right? Instead of allowing our code to linger for a month while we're waiting on a release cycle, right? We move closer to the Amazon model, where code goes out like every 10 seconds or whatever they say, right? So that it doesn't rot, right? Part of physics is thermodynamics. Second law of thermodynamics is entropy, right? Everything doesn't sit still, right? It rots, and there's a cost associated with that, and the same thing happens with software. So the faster we can get that software from ideation at the developer then out to the market making money for the business, the less additional costs will be associated with the inventory that we're maintaining, all right? So what this really teaches us is that the only initiatives that are going to positively impact performance are ones with increased throughput while simultaneously decreasing cost. We're seeing a lot of layoffs in the software industry now. I'm sure you've noticed that. But the problem with a layoff is that it's only looking at cost. So it's a temporary solution, right? I think what you're going to see is a lot of these businesses that haven't put a contingency in place to retain their throughput or even increase their throughput amidst these layoffs, they're not going to be healthier as a result of this, right? But knowing this principle is definitely what's led us to the DevOps feedback loop, you know, whatever you want to call it. You've seen multiple versions of this picture, I'm sure. Here's one that has a bit more of a software stack associated with it. But what's the difference between this and the way that we deployed software when I was coming up in the 90s, when like literally you would like compile your code, stick it on a drive, walk it over to like a QA team so that they could test it for 3 months, and by the time your code gets out, it's already obsolete, right? We were fixing that problem by having a continuum that always moves the conveyor belt forward, right? That's how DevOps works. We fail quickly. If we release, when I was coming up again, if we released a bug or something wrong with the software, you would have to pull the release, right? Now we don't do that anymore, right? If we release a bug, okay, fine. Release the fix because we have a really nice automated pipeline to be able to do that. But that all came from this understanding that we had to decrease the distance between the creation of our inventory and that inventory creating throughput or money for the business. So there's a number of technical actions that you can take to be a more DevOps friendly company, right? You can choose supported free software and an open first policy, right? A lot of us already have this, right? My job before this was to evangelize open source in the enterprise, and I had a lot of fun doing that, but it get to a point where it was like I would go and talk and say, hey, you should have an open first policy. Yeah, thanks, we know, that's what we're doing. So it's kind of become standard practice now. You definitely want to deploy in cloud or container substrates with choreography. You want to decide on viable and relevant API management solutions. And you want to build a fail-fast culture. Again, going back to what I said before, that instead of pulling a bug out, no, just have a mechanism that can release a fix immediately. That's a fast failure. All right. So, speaking of free software, there are a lot of problems with closed development that I don't think we necessarily talk about or sort of coalesce enough. Difficulty or slowness in obtaining software and media. I actually think this is one of the most interesting things about open source, right? I mean, it's free software, great. But you've all, I'm sure, heard, free as in free speech, not free as in free beer. Or sometimes free as in free puppies, right? Because the puppy's free, but you got to feed it, you got to take care of it, right? There's different. But one of the most interesting things and important things is that you can just get your hands on it immediately, right? You can install it through your package manager or whatever, and then you can just have it. You have access to really good software. There's no barriers there. Inflexibility and growth and scaling, right? If we're going to have to increase our license costs as our seats increase, then we have to go and get approval from some part of the finance part of the company, and then we're slowed down. There's friction, no ability to modify feature sets, and inability to learn from and improve upon others' work, right? Less competitive risks here outweighed by a growth of community open source knowledge. This is a really interesting point here. There was an objection for a little while for companies actually making contributions to open source projects. And the objection was basically this, all right? Let's say that our competition is using the same open source product, and we spend our own resources to improve that product. Well, we've just also helped our competition who's using that software. And so they didn't, the thought was, well, we can't do that. We're going to be increasing the competitive edge of our competition. But really, the education and the benefit that you get from working directly with these communities far outweighs any of that risk. And that's pretty much borne itself out in most cases. And then less oversight, really less oversight, which leads to less security on the whole, right? The many eyes theory that Linus Torvald told us about. But this is not a new problem. Closed development has been going on for a long time. I like to call this sort of the alchemist's dilemma. So alchemy gets kind of a bad name, we kind of think of it as an ancient pseudoscience, and it certainly is, right? You had folks who were looking to try to create an elixir of life and all this kind of stuff. But some contributions were certainly made. Unfortunately, they were made in secret, right? Alchemists didn't talk with other alchemists and tell each other what they were doing, right? They were secretly trying to race for this elixir of life. And so they drank like mercury and arsenic and stuff like that and got really sick, but they didn't share that with other people, right? So first of all, it's hard to even understand what their contributions were. But physical harm was actually caused by not sharing information with what they were discovering, right? We can go back even further and talk about this guy, Pythagoras, right? If you're not super familiar with the life of Pythagoras, you probably at least had to learn this equation in school, Pythagorean theorem, the way to calculate the hypotenuse of a right triangle. Pythagoras had sort of an interesting setup. He had a school of geometry in a city called Crotone, which is basically in southern Italy now. And the important thing to understand about the geometry that Pythagoras was teaching was that it wasn't just math back then, right? Pythagoras actually thought that math was sort of a divine language of nature, right? He believed that all entities actually resonated musical harmonies. He was one of the first people to really understand or to at least publicly understand the relationship of math to music, right? But more importantly, the populace, the people, they looked at the geometry that he was making and made the association that geometry is what allowed us to build aqueducts and buildings and build a whole substrate for our society, right, at the time. Not unlike the software that we build now, which produces so much of the infrastructure that we live in, and that looks like magic to a lot of people who don't understand what we do. you know. My my wife is non-technical, and she's funny. She'll say, you know, don't ask Justin what he does for a living because he'll tell you, you know. But and you know, again, it looks like magic to folks who don't understand, but we know it's not, right? We know it's not. We're practitioners. We've dug into it. We understand how this thing works. But it's very similar to the way that people thought about geometry back in ancient Cretonne. So unfortunately, Pythagoras created a very secretive sort of inner circle type of structure around his school in Cretonne. You had the inner circle, the mathematicoi, or the learners, as they were, and they were the only ones who were actually allowed to learn geometry. And Pythagoras was kind of there wasn't really a lot of logic between who he'd pick. He was just like, okay, I think you can learn geometry, I think you can. Then the outer circle of the school were called the acousmatics, or the listeners. And they were kind of just like servants to the school. Like they went just running chores and stuff like that, right? So the problem with this is that we attribute the Pythagorean theorem to Pythagoras, but we don't know if he actually wrote that. It might have been one of his students, another member of the mathematicoi. So it's very difficult to sort of attribute that work. But it gets worse. Along comes a guy named Cylon. Not that Cylon. Cylon was a nobleman from Cretonne. He was a leading citizen, and he had felt like he had sort of a birthright. He wanted to be accepted into Pythagoras' inner circle. Nobility is a hard thing for us to understand in modern times, but people really did believe that there were a class of people sort of divined to be the upper class, the noble people, and then everybody else were just kind of peasants, and that's just how life was, right? We would get past this, which we're going to talk about. But Cylon really wanted to be accepted into the inner circle. He really wanted to be able to learn geometry. And being a nobleman, again, he considered it his birthright. Pythagoras refused his requests over and over again, wouldn't let him into the inner circle. So he was exiled. Cylon revolted against the Pythagorean school in 509 BC. A lot of the students were killed in the revolt. And as a result, Pythagoras died in exile, all because he wouldn't share geometry with the world. Now, thankfully, we would move to a place sort of out of all of this superstition and belief in divine birthright as we would move into this period called the Age of Enlightenment, which is often summed up by this quote from Immanuel Kant: "Dare to know, have courage to use your own reason." At the time, this is a revolutionary thought, right? You follow the nobility. You follow the people who run society, and if they say a thing is true, it's true. But Kant said, no, everybody's the same, right? We all have an intellectual capacity. We all have the capacity to be curious and to use our own reason. A lot of people sort of place the beginning of the Age of Enlightenment with Sir Francis Bacon's publication of the Novum Organum. So, as always, Bacon makes everything better. And this would introduce Francis Bacon's theory of reductionism, right? Which meant that if we wanted to solve a problem, we had to break it down to its individual components. The prevailing theory at the time was Hermeticism. You know, if you've heard as above, so below, what happens in the cosmos happens down here, and that's how we predict things. And Francis Bacon said, I think that's kind of BS. I think actually the way that things work is that things that need to be reduced down to their basic components, and that's how we can explain how things work. And again, another revolutionary thought, which would lead us into championing the individual and understanding the importance of the individual, which is a big part of the Age of Enlightenment. But these principles, for anybody who's worked within open communities or open source communities, or even benefited from them, should seem very, very similar, right? The sharing of ideas through publication. Instead of an inner circle, these ideas are available to everybody, right? The rise of the public sphere or the public domain, right? Art and creation and knowledge that belongs not to just a small group of people, but belongs to everybody within the public domain. Individual liberty and creative freedom. Again, we take these things for granted now, but this was not part of the zeitgeist of the time. And then also the scientific method and reductionism, would come out of this. Then we had the world's first open source contributor, Sir Isaac Newton, who did something very, very interesting. He published a book called Principia Mathematica, where everything that he learned about geometry and algebra and the other types of math that he was calculus, all these things, they were published in this book and made available to everyone, to all mathematicians, to all engineers who wanted to be able to take what he learned and discovered and make it their own, and make their own discoveries, right? That's open source, right? That's knowledge out in the public domain. You saw other examples of this too, the Florentine Bodega. These were areas where philosophers and artists and thinkers and scientists would come together and discuss things. Leonardo da Vinci was discovered in a Florentine bodega. And the Parisian Salon was a similar thing, where people would come together and talk about the ideas of the time and figure out how they could solve these problems together. It's kind of like GitHub, if you'll take that sort of intellectual leap, right? The ability to code socially together, right? So let's fast forward a little bit and see where all this took us. Well, it took us here. Some people love this and some people hate this. This is the CNCF cloud native landscape. Obviously a highly fragmented landscape, but this is what's building the infrastructure of our time, and a lot of this is open source software, obviously. Thankfully, the CNCF has provided this very handy trail guide. If you haven't taken a look at this before, it's really a very nice piece of content, which is sort of their recommended path to cloud readiness. But how has this changed software? Right? How has this changed the way that we have to develop software? Well, a long time ago in a data center far, far away, when I was coming up, if you wanted to deploy an application, you had to go buy a $10,000 server from HP or Dell or IBM, put it up in your data center, stick one application on it that would effectively use maybe 2% of the overall resources on that server, but the application was isolated. Right? We can't run 15 production applications on the same server. They're going to starve resources and all these things. So we came up with virtualization, right? I think we're all kind of familiar with this. Now we can take server resources and slice them up into individual virtual emulated machines, and we can deploy our applications that way. So this was a leap, but still not as far as we could get. It's always important to remember, I think sometimes, especially when we're in the weeds creating applications, that at the end of the day, the business only cares about the app, right? We may want to have wonderful conversations about Kubernetes and service mesh and all these things. You know what the business cares about? None of that. Is the app up? Is it running? Is it making money for the business? Great. So at the end of the day, that's what we have to make sure we're maintaining. So virtualization was a great start for this. But obviously, we did better than VMs. All right? Virtualization was certainly much more efficient, but not as efficient as it could be, because we had to install an operating system on every single one of the VMs. We had to treat them as emulated computers on their own, and those operating system, the operating system resource is not free, right? So, I mean, all these individual OS installs. So there's got to be a better way, which we know. We created containers, right? Now, rather than the entire virtual machine kind of running, we're able to create this cool software file system hack where a single OS kernel can now run multiple POSIX compliant file systems. And as far as the app knows, just like when it was running in a VM, it doesn't know any differently. It runs fine, the app runs fine, the business is happy. They're isolated, obviously, but all powered by the same underlying OS. So we've got a single physical machine now and a single kernel that's able to support all these different applications. All right, great. That is where we kind of are today. This has created the need now for a whole new ecosystem. So because of the fact that we have, again, had a paradigm shift in the way that applications can actually run, now we need a whole bunch of supporting software, like that big, crazy landscape diagram that I showed you earlier. Microservice landscapes tend to be a bunch of small, independent apps, right? If you're kind of doing it right, the microservice should be an app by its own right. But that means it's going to need the same thing that an application needs, right? It's going to need access to networking and storage. something to manage the lifecycle of the application, orchestration, network fabric, and everything else that an application needs. And so we came up with Kubernetes, right? Now, this is not another Kubernetes talk, right? This is really leading into the fact that, yes, Kubernetes is an ecosystem, an open source platform for deploying and scaling apps. I don't need to expound on this. I think we all know what Kubernetes is. But what really matters is that, again, this shift has changed the way that we write software. Who's familiar with the 12-factor app? Oh, good. A lot of you. Great. Excellent. So 12-factor development is a method of development that allows our code to be extremely portable and can work well in ephemeral environments, right? Which most of our monolithic code doesn't do very well with, right? We can deploy it in one place, but if we were to turn around and take it and put it in some other substrate, there's a good chance it's going to fail. We won't go through all of the 12 factors, but if you look at a few of these, they should maybe ring true, or at least kind of see how this could lead to code that is ultra portable. Look, for instance, at number 11 here, logs. Treating logs like event streams. Who loves trying to figure out the output of some failure in some ephemeral pod that's destroyed itself, and you have no idea what was going on in that application? Anybody love that? Nobody loves that, right? So instead, we need the application to take the events that are happening and push them out somewhere else, treating our logs like event streams as opposed to just some nebulous text file that we have to go find somewhere. Disposability. The app should be able to destroy itself and recreate itself with full parity. Nothing should be different, right? Configuration should live in the environment where it's closest to the application and where it can be manipulated by administrators. So all of these principles, are really in service to the fact that, again, we fundamentally changed the way that we're deploying software. So I hope you're sort of seeing the progression here. I know that this talk is a little bit all over the place, but you can kind of look at how open source fed a DevOps landscape, changed the way that we fundamentally deploy and use our software, which then came back full circle and changed the way that we have to write our software, okay? So all of this sort of begs the question, I think, what comes next, right? What's next after DevOps? So, and forgive me if you came to my talk yesterday because you saw this picture already, but I think it's really important. I think we often forget that software is the process of writing software is a fundamentally creative process, right? Now, it's a blend of things, right? It's creativity, but it's also science, right? On the one hand, we're visualizing a problem in our head. We're figuring out how can we solve this problem. But then we do something very interesting. We turn around and create code, a hypothesis with the build toolchain, and we say, hey, did I do this right? Right? Did I get my feedback? And the build system has to tell me, yes, you solved this problem. Like, this was great. So when things are good and we're in our state of creative flow, this is ecstatic, right? The brain has been mapped while people are writing code. And it's this amazing soup of right and left-brained activity going on in the brain. That's why this feels so good for us. When we sit down to code and we're uninterrupted at our work, hours can go by, right? And there's a feeling of ecstasy every single time that we get that positive feedback back from the tool chain. It gives us a dopamine hit that lets us kind of move to the next task that we want to accomplish, right? And so being in the state of creative flow is like any state of creative flow. And you can explain this to people who have never written software in their lives, but maybe they're athletes, maybe they love to run, maybe they're artists, and they love to create. All of these things involve a state of creative flow. But one thing that's really important for a state of creative flow is that it's not interrupted, right? That something doesn't pull our focus away from what we're doing. So you can imagine these kids are feeling great because they are learning how to code, right? Maybe they just ran system.out.println hello world, went go, and went up on the screen like, oh, wow, that worked. That's amazing. Dopamine, everything. I'm going to move on to my next thing. Kotlin, maybe they just ran a println hello world. But either way, they got their feedback immediately. They ran a simple program as they're learning to code, and the feedback came to them immediately. But I want you to imagine for a second that these kids were waiting 45 seconds, a minute, 10 minutes, an hour, 10 hours. I've seen extreme cases. You look at the Apache Tika project, it takes almost 48 hours to run the full corpus of tests against that project, right? Now, if these kids were waiting that amount of time to get the feedback that they were after, they're not going to look like this. They're going to look like this. And they're probably going to go find some other hobby. Well, this is no different than us, right? I mean, if we look at where the primary bottlenecks are now sitting in DevOps mature organizations, it's no longer in the area of software deployment. Now the bottlenecks have shifted very far left with developers who are waiting way too long for builds to complete, or dealing with flaky tests, or totally avoidable failures, right? All this toil and friction and frustration that can be part of the development process. It's time we need to do something about this now. DevOps was supposed to encompass all of it, but it hasn't, let's be honest. It hasn't done very much at all for the developer experience. And at the end of the day, developer productivity and developer happiness are the same thing. You go back and look at that brain chemistry that happens when we're in our flow state. Productive developers are joyful developers are productive developers. There's no difference between these things. But it doesn't come without some discipline. Anybody doing this? Tracking local build and test times? I'm not talking about, thank you, a couple of people, yeah. I'm not talking about, Jenkins metrics, or I'm really talking about what is the developer doing right there at their laptop? Well, we know that what gets measured gets improved, but so few people are even measuring this metric, which is kind of the quantum unit of developer experience, is the feedback cycle time, right? What is development? But think code, compile, get the feedback, think code, compile, get the feedback, think code, compile, get the feedback, over and over and over and over again. That's essentially the developer experience. And the length of time between doing the work and getting the feedback is the difference between a really good developer experience and a really horrible developer experience, right? So what is this practice of developer productivity engineering? This comes hot on the heels of DevOps. It's a relatively new emerging practice. It came out of the Bay Area in around 2016. The flagship companies that were doing this practice of developer productivity engineering are companies like Netflix, LinkedIn, Twitter, Uber, Square, Spotify, right? Folks who really understood that they had become DevOps mature, but that there were still major primary bottlenecks to their throughput. So one thing that all these different practices, again, reaching back into the ancient business wisdom of the 70s and 80s, one of these things that all these practices had in common is that they all simultaneously decrease cost while increase throughput, right? All of them. Just-in-time manufacturing back in the 70s, business process reengineering in the 80s, change management in the 90s. Then software ate the world, and these productivity practices became agile and lean and Six Sigma, which would lead into DevOps. And finally, if you really look at what we're doing, we're just chasing bottlenecks. This all comes back to the theory of constraints. This all comes back to value stream mapping, right? Where are the bottlenecks that are keeping our inventory from becoming throughput, right? Where is that happening? Now, we've seen this really interesting sort of a glue between DevOps and developer productivity engineering called platform engineering. But if you look at the microeconomics of this, it's very interesting. If you look at the career path of, for instance, the productivity engineers who work at Netflix, Twitter, a lot of these folks were DevOps engineers. Then they became platform engineers. Then they became productivity engineers, right? Just marching left and trying to solve these problems. So it's really time for this now. And luckily, I think the market's kind of paying attention. Part of my role as field CTO is analyst relations. So I have a seat with the Gartner Analytics company. And they run a survey every year called the CEO survey. Talk about what's kind of top of mind for CEOs right now. What are they thinking about? Back in 2020, pre-pandemic, pre-huge push for digital transformation that happened as a result of that, single-digit concern for developer experience from CEOs in the CEO survey. It was like 7% or something like that reported that developer experience was on their radar. Fast forward to the 2022 Gartner CEO report, over 70% concern around the developer experience. All right, so the landscape has shifted, right? And now we need to be thinking seriously about how we can improve developer experience. The good thing is we're engineers. We can think about productivity from a standpoint of telemetry. We can treat our development environments as if they were production environments, because they are. They're environments where developers are writing code, right? So DPE takes an engineering approach to productivity. It uses acceleration and analytic technologies to improve DevX, and it aligns with all the strategic management of goals of the company, increase throughput, decrease cost, all of these things. To be really clear on the problems that DPE solves, we can just kind of take a look at this. If you can imagine for a moment that this person on the left here is a developer, and the things kind of encircle them are feedback cycles, right? These are feedback cycles. And it could be local environment, remote environment, CI environment. Sometimes things are fine, but sometimes things take too long. We talked a little bit about that, right? The barrier to throughput being the feedback cycle time. Sometimes things take too long to fix. It's not that if your build goes red, that you're immediately pulled out of your flow state. That's not what happens. We know that. A new problem to solve. Great, we love solving problems. That's what we do, right? Great, new problem to solve. But if 45 minutes later, you're still trying to dig around in the system for the data that you need to root cause your problem, or you're waiting on some CI engineer to get back to you about something that was going on in the environment, nah, we're out of flow state. We're experiencing friction, frustration, and toil. And then the worst one, the problem that we could have eliminated if we were just observing it properly and being proactive about it. These are things like avoidable failures, infrastructure failures during test cycles, or flaky tests, which can sometimes be a result of those infrastructure things. Who's got flaky tests? Everybody. Everybody, right? We all do. And what do we usually do with them? Ignore them. Right? Red, green, good, done. Do the pull request, right? Spotify calls flaky tests the infinite pit of sorrow for developers, because not only are they horrible to debug, but they're completely demoralizing as you kind of lose your faith in the test, in the test set. But there are things we can do to detect them. We can put them on dashboards. We can take action proactively. And what does that do? That eliminates the possibility of the developer even running into this problem in the first place, which is what they deserve. This isn't a talk about DPE, so that's about all I'm going to say. If you want to learn more about DPE, though, we have this really great program that is a self-paced sort of knowledge journey. If you don't get the QR code now or whatever, you can actually pick up we have a business card in our booth where you can learn about this. And not only is it free and kind of self-paced, it's actually gamified. Right? So as you move through the different challenges, you'll actually earn points for doing it, and you can spend those points on real things. You can spend it on Legos and headsets and Gradle swag and all kinds of stuff. So a really fun way to sort of learn more about this practice if this is intriguing to you. We also have our Learning Center that's set up here. We have a number of different things. You'll see a lot of content there, but also we have different webinars and things like that where you can learn from some of the real luminaries, people coming from these companies that I mentioned earlier, like the Netflixes and the Twitters and the LinkedIns, and I shouldn't mention Twitter, but LinkedIn and other companies like that, Spotify's, who are really doing this well. You know, like Uber has 300 engineers that are just developer productivity engineers to serve all the rest of the engineering organization, right? And then finally, we did write a book about this, which you'll see if you kind of go through that knowledge journey. Not in physical form yet, 81 pages, written primarily by Hans Doctor, inventor of Gradle, my boss, but you'll only see Gradle on the front cover of this. This book is meant to be very vendor agnostic. It doesn't prescribe any particular set of tools. It really just tells you what metrics you should be looking at. You know, how can you intentionally fix your issues with developer productivity? So I hope you get a chance to look at that. And I just want to say thanks again for your time. Truly an honor to be in front of all of you. I hope that this was fun and informative, and enjoy the rest of the day.